In this problem, we have a particle moving to the xy plane in position x of t and y of t, and we have the velocity of each particle. So for number A, we have to find the speed of the particle at time t equals to 1.2. We know that the formula for the speed is square root of x prime of t squared plus y prime of t squared. It'll come out to be 1.271. We have to find the acceleration, which is x double prime of t, and y double prime of t, which is taking derivative of the velocity vector that we already have. So let's do that. Acceleration is x double prime t, comma y double prime t, and in this case, we know that it is going to come out 6.247, comma 0.405. This is simply taking derivative of this given velocity vector and plugging in t equals to 1.2. So let's move on to B. B has us find the total distance traveled by the particle over the time interval 0 to 1.2. So this means we have to find the arc length. We know that the formula for arc length is integral from the first position to the second position time, and basically putting the same component for speed, which is x prime of t squared plus y prime of t squared and dt, like this. So let's plug that into calculator. This is simply integral from 0 to 1.2 square root t minus 1 times e to the t squared plus sine of t to the 1.25 squared dt. So that comes out to be 1.010. So that's our arc length, which is the distance. So let's move on to C. C wants us to find the point which is the farthest to the left for t is greater than 0. So what it means to be farthest to the left is it means the minimum of the particle position. To find minimum, we have to find where x prime of t equals 0 and change the sign. Especially change the sign from negative to positive. So let's see where x prime of t equals to 0 in a calculator. It comes up to be when t equals to 1, x of t has relative minimum, means the particle is farthest to the left at t equals to 1. So let's find the position of the particle when t is equal to 1. We know this from the fundamental theorem. In other words, x of 1 equals to x of 0 plus integral from 0 to 1 x prime of t dt. Since we know x prime of t, we just have to plug this into calculator, which comes out to be negative 2.604. We need to do the same thing to find the y coordinate. So y1 equals to y0 plus integral from 0 to 1 y prime of t dt, which turns out to be 5.410. So we know that the coordinate at t equals to 1 is negative 2.604, comma 5.410. Next, we need to explain why there is no point at which the particle is farthest to the right for t is greater or equal to 0. We know that f prime of t is greater than 0 for t is greater than 1. That means there's going to be no relative maximum or absolute maximum. It means that x of t is just going to be increasing for t is greater than 0. So we can say, since there is no maximum value for t is greater or equal to 0, there is no point farthest to the right.